The engineering field has contributed immensely towards changing how the world works. In many ways, the innovations and inventions over the last few decades have been nothing short of incredible. However, there have also been some tragic and unforgettable engineering catastrophes. These disasters have generally resulted from a mixture of design failures, under or overestimations, acting on insufficient knowledge, and other factors. In today's video, we are going to talk about the top engineering fails. So, make sure to watch the video till the end, and if you are new to the channel, make sure to subscribe to the channel and hit the bell icon, so you won't miss any future videos we upload. Number 1. Ariane 5 Flight 501. Few events in the realm of space exploration have left as lasting an impact as the ill-fated Ariane 5 Flight 501, which launched on June 4, 1996, from the Guiana Space Center in Kourou, French Guiana. This mission held great promise for both the European Space Agency and the aerospace industry as a whole, but it took a tragic turn, exposing a critical mistake. Flight 501 was a vital component of the ambitious Ariane 5 program, a series of missions aimed at establishing Europe as a significant player in the space launch industry. The primary objective of this particular flight was to deploy 4 scientific satellites clustered for the study of Earth's magnetosphere. The launch occurred at 3:34 p.m. local time, with the initial liftoff and ascent appearing flawless. The rocket, symbolizing European space prowess, majestically soared into the sky, driven by immense thrust. Tragedy struck just 40 seconds into the flight when a deviation in trajectory triggered the rocket's self-destruct mechanism, resulting in a spectacular explosion and the disintegration of the vehicle. Debris from the ill-fated rocket fell into the Atlantic Ocean, raising a multitude of questions. What went wrong, and why did such a promising mission end in fiery ruin? The answer lay in critical engineering mistakes. The guidance system of Ariane 5 reused software from the Ariane 4 program, despite the Ariane 5 being significantly more powerful and possessing different flight characteristics than its predecessor. The reused software failed to account for these differences, leading to a fatal error in the rocket's inertial reference system. The inertial reference system, designed to measure the rocket's orientation during flight, encountered an overflow error. This happened because the software was coded in a 64-bit floating point format, while the actual data was in a 16-bit signed integer format. When the system attempted to convert the large 64-bit numbers into the smaller 16-bit format, data overflow occurred, causing the rocket's onboard computer to shut down. This shutdown, in turn, triggered the rocket's self-destruct mechanism, as it could no longer maintain proper control over the vehicle's trajectory. Number 2. Manhattan Parking Garage. On a fateful Tuesday in 2023, a parking garage in Lower Manhattan, New York City, experienced a catastrophic collapse. Initial findings indicate that a combination of the structure's age and an excessive load on the roof played pivotal roles in this devastating failure, resulting in tragic consequences. Preliminary investigations have unveiled the factors contributing to the severity of this collapse. The building, dating back nearly a century, bore the weight of an aged history and an undue burden on its roof, leading to this engineering catastrophe. The N Street building, originally constructed in 1925, had a long history of use, as indicated by city records, with certification of occupancy dating back to January 1926. A subsequent certification issued in 1957 allowed for more than 5 motor vehicles on the cellar and the first 3 stories, specifying that the roof was suitable exclusively for passenger car-type vehicles. Records revealed that the building had previously accrued open violations, including one dating back to November 2003, which was classified as hazardous. This violation highlighted issues such as cracks in the first-floor ceiling slab and defective concrete with exposed rear cracks. Although a hearing had been scheduled for 2004, the matter remained unresolved. In 2019, a work permit was granted for the building to conduct electrical work necessary for accommodating general wiring required for car charging. In 2023, the sheer number of cars parked on top of the structure, estimated to be around 80 to 90 vehicles, may have pushed the limits beyond what the 100-year-old building could withstand. The cumulative weight, potentially reaching a staggering £250,000, is being examined as a possible catalyst for this tragic catastrophe. Number 3. The Tacoma Narrows Bridge. The Tacoma Narrows Bridge, a slender structure that once gracefully spanned the Tacoma Narrows Strait in Washington state, has secured its place in history as one of the most iconic engineering disasters. This ill-fated bridge, a combination of innovative design and overlooked factors, continues to serve as a cautionary tale of the unintended consequences of engineering innovation. The story of this bridge begins in the early 1940s when engineers envisioned a groundbreaking suspension bridge to connect Tacoma and the Kitsap Peninsula. With its sweeping curves and a remarkable main span of 2,800 feet, this bridge aimed to revolutionize transportation in the region. Construction began in 1938, and by July 1940, the Tacoma Narrows Bridge stood as an engineering marvel poised to redefine modern infrastructure. However, on the blustery morning of November 7, 1940, the Tacoma Narrows Bridge would become synonymous with disaster. In just a few hours, the fate of this magnificent structure unraveled. Winds that day reached speeds of 40 miles per hour, leading to a phenomenon known as aeroelastic flutter, a destructive vibration caused by the interaction between the bridge's natural frequency and the wind's forces. As the wind buffeted the bridge, it began to oscillate violently. The center span, constructed with narrow and shallow girders, proved vulnerable to these forces. The bridge twisted and contorted in ways unforeseen by its designers, creating an airy, undulating motion that no bridge should ever exhibit. The catastrophic collapse of the bridge, captured in photographs and newsreels, remains a haunting image in the annals of engineering history. At around 11 a.m. on that fateful day, a massive section of the bridge's center span broke free and plunged into the narrow strait. Astonishingly, there were no casualties, but the bridge's demise marked a costly and dramatic engineering failure. The root cause of this collapse lay in a series of design flaws. The bridge's slender profile, combined with the shallow depth of its girders, left it vulnerable to aerodynamic forces. The aerodynamic flutter induced by the strong winds pushed the bridge beyond its structural limits. These aerodynamic phenomena, compounded by the bridge's natural frequency, ultimately led to its collapse. The aftermath of the Tacoma Narrows Bridge collapse triggered a period of introspection for engineers and the general public. It prompted a re-evaluation of engineering principles, particularly those related to the aerodynamic stability of suspension bridges. The lessons learned from this failure would go on to inform subsequent designs and safety protocols in the field of civil engineering. Number 4. Arts Pedregal Collapse. Arts Pedregal was a high-end shopping mall located in Mexico City, designed to cater to the city's more affluent residents, offering a range of luxury boutiques. Its construction was successfully finished in 2018, adding a notable feature to the city's skyline. However, this remarkable architectural achievement took a tragic turn on July 12, 2018, when a devastating structural failure resulted in a portion of the mall collapsing. This incident occurred amid heavy and continuous rainstorms that had been affecting Mexico City for several days, sending shockwaves through the community. The collapse can be primarily attributed to a combination of factors. Weaknesses in the mall's design and construction became evident as it struggled to endure the relentless rain. The mall's hillside location exacerbated the situation, as saturated ground imposed tremendous pressure on the building's foundation. Reports also pointed to improper drainage systems and inadequate water management as significant contributors to this disaster. The moment of the collapse was captured on video, portraying a dramatic scene in which a sizable section of the mall's rooftop parking lot gave way. The force of the collapse sent debris crashing onto vehicles and caused significant damage to the lower levels. Fortunately, swift evacuation efforts and a stroke of luck meant that no lives were lost in this incident. That was all for today's video. You can share with us your views in the comment section, and if you are new to the channel, remember to subscribe to the channel and hit the bell icon so you won't miss any future videos we upload. Thank you for watching the video. Best of luck and goodbye.